Hi, I'm Don Bourne, the WebSphere Serviceability Architect. I'm going to be talking to you today about two exciting new features that we've added to the WebSphere application server: high-performance extensible logging and cross-component trace. I'm going to talk to you now about high-performance extensible logging, or HPEL for short. HPEL has been available since WAS version 8.0 and provides a new way for storing log and trace content to disk. The first thing you'll notice is that HPEL greatly improves your log and trace performance, so if you need to run with trace on in your production system, HPEL is much less invasive on. A second benefit is that log and trace content is much easier to filter with HPEL. You can use it to find anything in your log and trace content quickly. A third benefit is that HPEL is available on all operating systems and provides a consistent user experience. Take a look at this web page that we use to drive log and trace workload against our server. Let's set this up to run 8 concurrent threads for 30 seconds to drive a trace workload against first our default log and trace framework and then our HPEL framework. As the test runs, it outputs the number of records it's written to the disk once per second. Here you can see the default log and trace framework. On our summary page, you can see that the default log and trace framework has logged about 68,000 entries per second. Now let's switch the server to HPEL mode. Expand troubleshooting, click logs and trace, pick your server, and hit the button to switch over to HPEL. Once you click Save and restart your server, it will be in HPEL mode. Now let's rerun the same test case with HPEL. HPEL stores log and trace records in a binary format. So that you can view it, we've provided a log viewer command in your profile bin directory. The log viewer command is what you use to do everything from view your log files, to tail them with the dash monitor option, or filter them in interesting ways. There's also an API if your developers want to get at your log and trace files directly. On the result page, you can see that HPEL drove over 353,000 entries in the same amount of time with the same number of threads. HPEL saves log, trace, system out, and system error into repositories in a binary format. By running the log viewer command with no options, all the content is output into a basic format. Each run of the server is stored into a separate repository. We call these server instances. By running the log viewer -list instances command, you can see the list of instances that are available. Using log viewer -instance, you can see the log content from just one instance. You can use the latest instance option with log viewer to view the log content from the current instance, or the most recent instance if your server is not running right now. If you just want to see warning messages and anything more severe, you can use log viewer with the min level warning option. As you can see, you can combine filtering options. If you'd like to only see the content from one thread in your server, you can use the -thread option. If you'd like to filter out one or more of the loggers, you can use the exclude loggers option. You'll notice you can also use wildcards with that. The log viewer command lets you output your log records in a variety of formats. For example, the default is the basic format, but if you use -format advanced, you can see your records in advanced format. In an advanced format, the header contains additional information about each record. You can see the source attribute specifies the logger name. You can see the thread attribute specifies the name of the thread, and the app name attribute specifies the name of the application that wrote your log and trace entry. If you use the include extensions option, you can also filter based on the value of your extension, in this case app name. If you want to store the output of your log viewer command into another binary repository, perhaps with the content filtered, use the Extract to New Repository option. Once you've stored the content into your new repository, you can use the repository dir option to specify the location of it. You can also add in additional filter parameters if you'd like to continue to filter on that repository. Any of the filter parameters are accepted. If you have a repository from a ZOS system, you'll notice that when you run the log viewer command, the default is to show the list instances output. On ZOS, the repository is divided into records that came from the controller, servant, and adjunct regions. As with repositories from other operating systems, on Z, use the instance option to output records from a particular instance. The admin console contains a useful viewer for HPEL content. Even if you only have the node agent up on the system, you can access the log and trace content from a remote server. You can use the Content and Filtering Details section at the top to specify filter settings that you'd like to use. Hit the Apply button after you've specified your settings, and the table is updated to show you what you've asked for. You can also export content from a remote server back to your client where your browser is running. You can specify a binary format or a particular format that you'd like to see the logs in. If you open the file up that you get back from the remote server, you'll notice it's in the same format as if you'd run the log viewer command at the command line. Now let's talk about cross-component trace, which has been available since WAS version 8.5. Cross-component trace is a log and trace correlation technology. It makes it easy to view a single request in your log and trace separated from all the other content. It also makes it easy to see a request that has flown across multiple threads or processes. To enable cross-component trace or change cross-component trace settings, you can use the admin console. Navigate to the same panel that you would use to change log detail level settings. On that panel, in the correlation section, check the box that says Enable Log and Trace Correlation. You'll notice there are 3 different levels at which you can enable cross-component trace. We'll talk about those more. To show how to use cross-component trace, I'll illustrate with the Snoop servlet. I'll use the log viewer command to monitor the log repository while I run the Snoop servlet. To make things easy to read, I'll filter for the Snoop word inside the message, and I'll format the records in advanced format. Cross-component trace adds a request ID extension to each log and trace record. This information helps you to identify which request a particular log or trace entry was originated from. As you saw previously when we had the app name extension, you can use the request ID extension with the include extensions option to filter your log and trace content by request ID. As you saw before, there are 3 different levels at which you can enable cross-component trace. At the first level, we get the request IDs. At the second level, we'll get the request IDs, but we'll also get XCT begin and end markers in our log files to help us see when work started and ended on a particular thread. To illustrate the value of the cross-component trace begin and end entries, I've got 2 separate HPEL repositories from 2 separate JVMs. The first is from a proxy server. Let's take a look at the content of records in the proxy server log as the Snoop servlet was executed with cross-component trace in the second mode. As you can see, there are a number of XCT records in this log. The first two records come from the request coming inbound to the proxy server. As the work is sent outbound from the proxy server to the base WAS server, you'll see the begin and end for that work. Finally, when the response comes back from the server, you'll see the proxy server receive that. You'll also notice the call chain IDs. Notice that the end of one call chain is the beginning of the next call chain. This gives us the ability to piece together the order of which operations occurred, and as you'll see in a moment, you can also use tools to operate on the call chain information. Now let's take a look on the server side. Using the same command, we can use the log viewer to look at the records from the server log. This time you'll notice that the begin and end entries are only in one pair. This is because the entire request is handled on one thread. You can see the inbound request with the URL and the return code as the request is finished. If you've got the WebSphere application server, you can grab the IBM Support Assistant. With the IBM Support Assistant, you can download the IBM WebSphere Cross-Component Trace Log Viewer. This tool makes it easy to look at log content that comes with XCT entries embedded in it. What we'll do now is load up both the server and proxy logs at the same time, and you'll notice that the log viewing tool actually puts the records together as if they were part of the same request. You'll notice I've also converted the files into text, into log files, so that they're readable by this tool. Now you'll see the green and orange icons for the start and end. These correspond to the begin and end records from XCT. Let's highlight for a moment the records that came from the proxy. These correspond to the same 6 records that we looked at before. Similarly, you can see the other 2 records that came from the server. Thank you for taking the time to learn about high-performance extensible logging and cross-component trace. I hope this session was helpful for you.